So good day again, everyone. So today we're going to answer exercise 3.1 of under chapter 3, which is motion in two or three dimensions. So this is under the topic session 3.1, which is position and velocity vectors. Okay. So we are still using the University Physics with Modern Physics 13th edition. And I am Prudence Peace Bustamante again from Surigao del Norte State University. Okay. So uh, so exercise 3.1. So a squirrel has x and y coordinates which 1.1 meters and 3.4 meters. So that's the coordinate of squirrel at a time t1 is equal to 0. And the coordinates 5.3 meters and negative 0.5 meters at time t is equal to 3.0 seconds. For this time interval, find the components of the average velocity and the magnitude and the direction of the average velocity. Okay, so here without uh, having a graph or diagram, let's answer this problem. Okay, so here we have a coordinates. This is our x1. So say for example, this is our x1. This is our y1, and this is our x2, and this is our y2. Okay, so so the squirrel moved from this coordinate to this final coordinate. Okay, so from the definition of the average velocity, so for the x-axis, so we have the x2, the displacement along x over the time interval. Okay, or this is actually the time interval is actually T2 minus T1, which we know that T1 is equal to 0, so this is equal to 3.0 seconds. Okay, for our position x2, so our x2 is 5.3 meters minus x1 1.1 meters. We divide this one by 3.0 seconds. Okay, let's use our calculator. Okay, bear with me. Okay, so 5.3 minus 1.1 divided by 3. So this is equal to 1.4 meters per second. So that's our velocity along x-axis because we are now in two dimensions. So our average velocity along y, okay, is equal to y2 minus y1 over this time interval, which will give us our y2 is negative 0.5 meters minus 3.4 meters. We divide this one by the time interval, which is 3.0 seconds. Okay, so we have negative 0.5 minus 3.4 uh, divided by 3. So we will have 1.3 meters per second, negative 1.3 meters per second. Okay, how to find so that's for letter A. This is for letter A. So you find the x and y components of the average velocity. And for letter B, find the magnitude and direction. So to find the magnitudes, we use the knowledge of vectors that the magnitudes or the average velocity is just equal to, or if we have this average velocity, the magnitude is just equal to the square root of uh, V average along x squared plus V average along y squared. Okay. So this is actually, so the square root, this is actually square root of 1.4 squared plus uh, negative 1.3 squared. So you will have, so just input this 1.4. So or I'm gonna write this one 1.4 meters per second squared plus negative 1.3 meters per second squared. So you will have 1.9 meters per second. So that's the magnitude. So how do you how can you find out the direction? So what is the direction of the average velocity? If you make an x and y coordinate, okay. So this is your x, y, this is your x, okay. So note that your x component is positive, so it is located here. So let's use another color, such as yellow for our illustration. Okay. So your x component is positive. So this is your V average along x. And however, your y component is negative. Okay. So this is V average along y. So that is so meaning your vector is in quadrant 4. So your vector is in quadrant 4. So this is your vector. So you know the magnitude of that vector. So this is your V average vector. So that is your vector. You know the component, but you don't know the direction yet. Okay, if you're gonna use this direction, for the direction, the tangent of angle theta is equal to opposite over, or we're gonna use this formula, which is the uh, uh, opposite V average along y over V average along x. So meaning this is implies that our theta is equal to the tangent inverse V a average along y over V average along x. So where is this theta here? Where is this theta located? So tangent meaning opposite, and this is adjacent. Okay, opposite over adjacent. So your opposite must be y. Okay, your opposite must be y. So theta must be here because the opposite is your I mean your y component is the opposite, and your x component is the adjacent. So that's your theta here. If you want to find the angle in that area, okay. So so shift tangent, which is uh, negative 1.3 over 1.4. So you will have 1.4. So you will have negative 42 point, okay, 42.9 degrees. So here from your positive x-axis, that is 42 degrees. Okay, that's theta is 42 degrees. So if you want from the positive x-axis, if you want to find the angle here from here, okay, so the direction of that is uh, 42.9 minus 360. So 300. So the angle from the positive x-axis is 317 degrees. Okay, point 0.1. 0.1 degrees. So you can put the direction as, you can finally write the direction in many other ways. So one could be, you can write the direction as, I'm gonna put it here. The direction is 42.9 degrees. Then this is actually south of, okay, south of east. So you can say that, or you can say that this is 317.1 degrees from the positive x-axis. So that is the answer. So you can use this one or you can use that. Okay, that's all for our uh, lesson for today. Exercise 3.1. For more videos like this, please click the likes and subscribe to our channel and click the notification bell for more uploads videos. If you have problems that you want us to answer, please write that in a comment section. So God bless and goodbye, everyone.